processing, unit number 4. So in this digital signal processing, basically we are having 6 units, and already unit number 3 explained by Dr. M.S. Chavan, and we are going to cover unit number 4, 5 and 6. So in the unit number 4 and 5 and 6, before that we should have a look on the objectives of the course outcomes or course objectives of the digital signal processing. So in the DSP, we study about the FFT algorithm, TFT algorithms, design of the FIR filter, design of the IR filter, as well as the realization of the FIR filter, IR filter, that we'll have to cover, and understand the DSP processor, concept of multi-rate digital signal processing. These points we'll have to cover, or these are the objectives of our course. Now, the next is what is the unit 4 objective, or in the realization of a filter. So basically there are objectives are realization of FIR and IR filter. So FIR filter, IR filter, different realization we are using. So basically thoroughly we are going to study about the direct form 1 realization, direct form 2 realization, cascade realization and the parallel realization. So what is the, before that, what is the overview of this one, means for the realization in backend, what knowledge you should have. So for that we have the awareness about the difference equation. So how the difference equation for the digital system or the digital signal, discrete signal we are using over there. So for that the difference equation is the combination of impulse response, the some system functions, and that is input output relation of a LTI system. So this is the difference equation. One example is mentioned here, y of n is equal to x of n plus x of n minus 1 plus and so on. So when you observe this difference equation, we are having an input x of n and output is y of n. From that we are using the impulse response, along with that we can use the impulse response h of n, and then we are going to calculate the transfer function h of z. So we have the awareness about the Z transform that you studied in the signal science system. Also we have awareness about the LTI system. We know about the discrete time signal. Now the next part is, while for the realization of the FIR filter and IR filter, which types of the components we are using for the realization. So these are the basic components we are using. The adder. Adder means if there are two inputs, we are using x of n and y of n. We are adding together, we'll get wn equal to x of n plus y of n. Similarly, multiplier. So constant multiplier, that is the symbol for the constant multiplier. X of n multiplied with the a constant multiplier, and we will get the output. The modulator x of n and y of n, it is a multiplication sign, and you will get the output here. Likewise, wn equal to xn into y of n. Then delay, if you want to introduce the delay in the system, so we will get the input x of n and multiply with delay, means x of n minus 1, not multiply, sorry. So x of n minus 1. If you want to add the advanced signal, that is x of n plus 1, means whole it is operated on the input signal, that is adder according to the inputs, then constant multiplier according to the input x of n into axn. Then we are using the modulator, that is x of n y of n. Then z minus 1 is it is operated on the x of n, and it is x of n minus 1, x of n plus 1. Okay. Now the next point is, here we are using the FIR filter structure. How we can realize the FIR filter structure? So for that, for the realization in the FIR filter, there are basically two forms. You already have the reference about the FIR filter you studied in unit number 2, right? FIR filter, how to design the FIR filter. And for design and practical implementation of a FIR filter, we require the realization of a filter. So in today's lecture, for the realization of FIR filter, it is a only zero system. It means that we are not having a numerator value, denominator value, we are having only numerator value. Because of that, it is mentioned that it is a only numerator part, and we know that it is a zero system. There is no poles are present in the system, in the FIR filter, because we know that there is no feedback. We are not taking the feedback, isn't it? It is a linear time invariant FIR system. So we have just go through the details about the FIR filter, which is already covered in the unit number 2. Then we are going to realize by using a direct form 1 and cascade form, direct form and the cascade form structure. Now, this is the direct FR filter structure, direct form structure. How we can realize FR filter? It is mentioned here. This is the example of FR filter. Y of n equal to h of 0, x of n. Likewise, up to x of n minus 4. So, we are having a fourth order FR filter difference equation, and for this difference equation, we require n plus 1 multipliers, because h of n multiplied with x of n, h of n multiplied with the x of n, and output we are going to achieve y of n. We require n adders and n delays. By using this is the structure of direct form FR1, direct form 1 FR filter realization. X of n is output, y of n is output, x of n is a input. So here h of 0, from the equation itself we are going to realize h of 0, x of n. So this is the multiplication symbol. It is multiplied to the x of n. Then we require x of n minus 1. So we added here one delay, and it is a x of n minus 1, which is multiplied by h of n, h of 1. Then this parameter h0 xn and h1 x of n minus 1 added. So we require adder. Likewise, we are going to complete this till x of n minus 4, which is mentioned in our example. So this is the x of n minus 4, this is the h of 4, then multiplication, then addition of this one, and that will get the final output y of n. Then the next part is direct form. Either we can use this is the optional, we can say that we are using a tap delay line, and using that also we can realize. I am not going to focus more about this one. Now this is the example to realize FR filter by using a direct form and the cascade structure. This is the 1 minus 1 upon 4 z plus 3 upon 8 z raised to 2, 3 upon z, right? So 3 upon 8 z raised to minus 2. Likewise, this is the equation, difference equation, or transfer function, we can say h of z is mentioned here, and then we are going to realize. Now how we can realize? See, observe this one, this is the transfer function 1 minus 3 upon 8 z minus 1. It is a simplify this. Above equation is simplified, and this is the structure by using a direct form. So we know that h of z is a yz upon xz, then inverse z transform, we are getting a y of n and x of n. Observe this equation, it is a 1 minus 3 upon 8 z minus 1. Thing is that using the z minus 1 delays here, we are using a adder here. So 1 minus 3 upon 8 z minus 1. So it is multiplied with, if you are using the y of n upon x of n. So x of n multiplied to the 3 upon 8 z minus 1. So 3 upon 8 minus 3 upon 8 is the multiplier. This is the multiplier symbol, x of n minus 1. Z minus 1 we are calling as x of n minus 1. We require a single delay, input is x of n. Likewise, here we required another delay, that is x of n minus 2. Here we required z minus 3, one more delay, x minus n minus 3, and n minus 4, that is a z raised to minus 4. When you observe this constant term minus 3 upon 8, it is a multiplier, minus 3 upon 32, 5 upon 64, minus 3 upon 16, and this is our final output we will get after the realization. Now this is the cascade realization. When you observe the given equation, there is a numerator part and the denominator part. So these two are separated and it is a cascaded together. So we can say that, just observe this equation, 1 minus 1 upon 4 z plus 3 upon 8 z raised to minus 2. Okay, and this is the another, sorry, not numerator and denominator, it is only numerator, but we are taking consideration, this is the h1z and this is the h2z. So h of z, h1z and h2z, the multiplication of that h1z and h2z cascaded together, and then we are going to realize. So this first bracket we are realize separately, another bracket we are realize separately, and then we are cascading together. So this is our structure. This is the h1z and h2z. So minus 1 upon 4, only here vertically we are, instead of this one, this is the another choice we can use, and this is again, it is using the direct form 1 combination of h1z and h2z. It is a cascade structure. So today we are going to cover about the realization of a FR filter by using the cascade structure and using a direct form 1. So I think this is enough for the today's lecture. The remaining IR filter system design that we cover in the next lecture. Thank you very much.